Sure, gang, welcome back to my YouTube channel. My name is Karabo Sithole, and in today's video, we are doing Business Statistics November Examination 2018. Before we get to that, guys, if you have not yet signed up for the Economics Bootcamp, please make sure that you hit me up on WhatsApp to get more details. As you guys know, I did the Stats Bootcamp, and right now I'm just helping those who could not make it because of cost constraints or because they didn't get space. So I'm going to be doing a November examination, but just to make sure that you are sorted for economics and you don't stress about it while in the stats examination, make sure that you sign up for the bootcamp, because honestly speaking, I might not get time to do summary videos. So just make sure that you are part of that bootcamp, because it's going to be lit. We're going to be pushing like crazy. We're going to be pushing like we are doing CTA. So just make sure that you are there. Don't miss out. Don't miss out, guys. You want to get home and make your parents proud. So if you are interested in the bootcamp, make sure that you sign up for it. Okay, without further ado, let's get right into today's work. So the first question says, the following data relate to the number of queries received per day by the computer technician of a small IT company. And then I'm given the number of queries and I'm given frequency. So once I see X values and I see frequency, it clicks in my mind that this is grouped data, right? Now I need to go and check if my X values are intervals or they are just single values. And because they are single values, then it's grouped discrete. So I take that into account, grouped discrete. So they say that the data was collected over 60 days. The mean and the first quartile, respectively, from the above data are. So I need to find the mean and I need to find the IQR. So I'm just going to show you guys how to do that on the calculator. So another thing is, when they give you the table and they are asking about measures of central tendency, your mean, okay, when they are asking for your mean and your standard deviation, okay, when they are asking for your measure of central tendency being the mean, as well as the measure of spread being your standard deviation and variance, use the calculator, and if you are given the table. But if you are given summary statistics, then you have to use the formula, right, given in your formula sheet. So in this case, we are given a table, so I'm going to go to the calculator. So for this basic scientific calculator, you press, since you need the frequency on, you're going to press shift mode, go down, and then press 3 for stat, frequency on 1, right? And then I just go to mode, right, 2 stat, and 1 for variance, right? And then it's going to be X and frequency. Then I put my values. My first value is going to be 0, 1, 2, 3, 4, 5. Right, 1, 2, 3, 4, 5, 6. Okay. Then my frequency 1, 5, 16, 21, 11, 6. All right, and then I press on. Don't press AC because it might cancel your data. Press on, shift 1, and then press 4 for variance. And then your mean is X bar, and then your standard deviation is SX. So press 2. So you see the mean that I have is 2,9. So I have only these two options, C and D, right? So now I need to find what? My IQR. I need to find my first quartile. And my first quartile is going to be P25, right? But before you do that, before doing a long calculation, just check if, because most students confuse the position and the percentile, just check if they didn't use that, right? So just check if there's no position here. And if there's a position given as your percentile, then you know that's the wrong answer, and the one that is left is your correct answer. So exam strategy. So what I'm going to do is to find the position for P25. So to find the position of R, it's going to be 25% times n plus 1. N is 60, so it's going to be 61. And your position should be 25% times 61, 15,25. So do you guys see what I mean? They know that students think that the position is your percentile, but this is the position. To find the percentile, you now need to go to the formula, right? Meaning that this is also false. So what is correct? C. But let us actually look at how to calculate the percentile itself, right? So as I said, this is group discrete data. My N is 60, my X bar is 2,9, right? I find the position. So the position is 25% because I'm looking for the 25th percentile. So it's going to be 25% 25 over 100, right, times n plus 1, so times 61, which is going to be equal to 15,25, and this is the position. In the position, I get my whole number, which is k, and I get my d, which is my decimal, right? And this is the formula I need to memorize. It's going to be PR is equal to xk plus d times xk plus 1 minus xk, right? And then what is xk? Xk is the value that you get when you go to position k. In position k here is number 15. But because this is group data, I need to find my cumulative frequency to be able to get that position. So it's going to be 1, right? And then it's going to be 6, and then 21, 22. Okay, then it's going to be 22, right? So the position that I have here is 15, right? So I need a cumulative frequency that is either equal to 15 or greater than 15, right? And that is here. So the number that I'm working with, remember, this is where the position is. This is where the percentile is, but I need that position. I need that x value, I mean. So the x value is 2. So I put my 2 plus my d. D is the decimal in your position. So it's 0.25. Then you take xk plus 1. K is 16, is 15, so plus 1, 16. So I'm looking for K 16 here. So this is X 16, right? I'm looking for the X value that corresponds to the 16th position. If you check, the 16th position is also in the same cumulative frequency position. So it's going to be 2 either way. So it's going to be 2 plus 0.25 times 2 minus 2, which is going to give you 2,00. That is why the answer is C, right? Let's go on to the next question. The next question says, an investment analyst examines 2 different investments. So we have 2 different investments. The probability of investment A showing a positive return is thought to be 0.30. So here there's no given. This is one statement, investment A showing a positive return. So this probability is showing me the probability of investment A showing a positive return, right? The whole thing, this is one statement. There's no conditional probability here because this is one statement. Investment A showing a positive return is thought to be 0.30. Then they say the probability of both A and B showing a positive return is thought to be 0.18, meaning that the statement investment B showing a positive return is also one statement. So what they are initially saying here is that the probability of A and B, right, their intersection is 0.18, right? They say if the return on investment, they even further hint to you that this is one statement. The return on investment A is independent of the return on investment B, meaning when I multiply A and B, it's going to give me their intersection, right? Because they are independent of each other, right? The probability of at least one, what does at least one? It means you can have 1 or you can have 2, right? Of the two investments showing a positive return, they still mention positive return, right? So this is what you do. First of all, you are told that A is independent of B, right? And A denotes positive return on investment A, B denotes positive return on investment B. The probability of A is given as 0.30, and now they tell you that the probability of A and B is equal to 0.18. And they further told you, right, that A and B are independent of each other, meaning to get this intersection, I need to multiply the probability of A and the probability of B to get 0.18. Right? And then you substitute the probability of A and solve for probability of B, right? And then if you take 0.18 divided by 0.30, you should get 0.60, right? Now you have the probability of A, you have the probability of B. They said the question is asking for the probability of at least 1, meaning you can have 1 or you can have 2, meaning you can have A or you can have B, right? So or means intersection. So you're going to take the probability of A, right, 0.30, plus the probability of B, 0.60. But remember, what does or mean? It means union, it means addition rule. And with the addition rule, I need to take into account the intersection. So you have to subtract the 0.18 being the intersection. And the answer that you get is 0.72. And D. And then we go on to question 3. Question 3 says, the lost and found department of ABC departmental store receives on average 3 telephone calls during the first 5 minutes of operation. And they tell me what 5 minutes is, between 9 to 9:05, right? Monday to Friday, meaning on any given day. On any given day, because they work Monday to Friday. If the number of calls follows a Poisson distribution, so I'm focusing on the number of calls, right? That is my subject. Follows a Poisson process, which of the following probabilities is incorrect? Right? Okay, let us analyze what this question is basically saying. So the question is telling me that on average, I receive 3 calls during the first 5 minutes. So meaning that lambda is 3 per 5 minutes on any given day, right? And what is X denoting? X is denoting the number of calls that I receive. So X is denoting the number of calls received. And they tell me that these number of calls, X, follows a Poisson distribution. Remember with Poisson, what is our parameter? It's lambda, right? So it's gonna be X follows Poisson with my lambda of 3. The lambda is not 5. The 5 tells me what's per what, right? The lambda here is actually the 3. So X follows Poisson with my lambda is 3 per 5 minutes, right? And then the first question says the probability to 4 decimal places of receiving no telephone calls. What did I denote telephone calls X as? I denoted them as X, right? So meaning no telephone calls means that the probability of X being equal to 0 next Monday between 9 a.m. and 9:05. So meaning in the first 5 minutes of operation, right? So I'm looking for the probability of X being equal to 0 in the first 5 minutes, and my lambda is per 5 minutes. So I'm still going to use the same lambda of 3. So this is the formula for lambda, which you find in your formula sheet. So you're going to be like e to the power of -3, the lambda, times lambda of 3 to the power of x, x is 0, over x factorial, and that x factorial is 0 factorial, right? And then you get that the answer is 0,0498, which is the same answer that I have here. So this is true, but I'm looking for what is false. The next question says the probability to 4 decimal places of receiving 2 telephone calls. What did I say? Telephone calls are denoted by X. So meaning I want the probability that X is equal to 2 during the first 5 minutes. So I'm still dealing with the same lambda because it's still per 5 minutes. I don't need to change the lambda, right? During the first 5 minutes of operation, tomorrow, meaning on any given day, is 0,2240, right? So I'm still using the same lambda of 3, but now I need to substitute X as 2 instead of 0. Same formula, e to the power of negative lambda, meaning e to the power of -3 times lambda of 3 to the power of X of 2 over 2 factorial. And when you put this in your calculator, you should get 0,2240. Let me just demonstrate how you need to do that. So in this calculator, the one that I have, you're going to put this shift e to the power of -3 times 3 to the power of 2 all over 2 factorial, right? And this is the answer that you get. So if you want to store this on this calculator, you press Shift RCL and you press any button that you want to store in. We have A, B, C, D, E, F, X, Y, M, right? So I want to store under A, so I just press A. So when I store under A, when I need it, I just go Shift A, right? And there's the value. Let me just demonstrate that again. So I have answer, right? So I press Shift RCL and then I press any button I want to store in. So I want to store under A, so I press A. Now it's stored under A. If I want it, I press alpha A, and then you find the value, right? And then C says, C says the probability to 4 decimal places of receiving at least, if someone says you need to be at least 18 to drink, does it mean when you are 18 you can drink or not drink? It means you can drink, right? So if they are saying the probability of at least 2, so meaning I'm looking for the probability of X being greater or equal to 2, it's very important to note whether you need to put this equal to sign or not, right? Because if you get it wrong, your answer is going to be wrong, right? But they said in the next Tuesday between 9, right, and 9:05. So I'm still using 5 minutes. So the same lambda of 3 is fine because it's per 5 minutes. So it's going to be greater than or equal to 2. But if you remember, what is the range of Poisson? The range of Poisson is that my X is going to start at 0, 1, 2, all the way to infinity, right? And infinity does not end, right? So they said they want the probability of X being greater or equal to 2, meaning I can have 2, I can have 3, I can 5, I can have 5, I can have 10,000, I can have 5,000. So you're going to keep on substituting each value in your formula No, because it's never going to end. So what you do is use the complement rule. So be mindful of the fact that you have an equal to here. So when you do the complement, it's going to be 1 minus the probability of x being less than 2 without the equal to sign, because it was already here and I'm looking for the complement, right? So that's what you do. You say 1 minus p of x being less than 2, right? And then 1 minus, what is less than 2? Less than 2 but not equal to 2 means I have 1 and I have 0. So it's going to be substituting 1 and 0 into the Poisson formula, and the answer that you get is 0,085. So this is going to be 9, right? So this is also true. So this was true, this was true. Now I'm on D. The probability of receiving 15 or 16 telephone calls, the probability of receiving 15 or 16 telephone calls is received during, okay, the English is not making sense, but during 9 and 9:30. So now the lambda needs to change, because the lambda I had was between 9 and 9:05. Now the lambda that they are looking for here is between 9 and 9:30, right? So I need to convert this 3 per 5 minutes to a new lambda per 30 minutes, right? So they give me the probability. So what do? I say 3 is equal to 5 minutes, right? So the new lambda is equal to 30 minutes, and then I cross multiply. 30 times 3 is 90. Lambda times 5 is 5 lambda, and then you divide the 90 by 5. So 90 divided by 5 is 18 lambda per 30 minutes. Right? And what probability am I looking for? The probability of 15 or 16. Or means addition. So it's going to be the probability of x being equal to 15 plus the probability of x being equal to 16. And you add those together. So the answer that you get is actually going to be 0,1670. Right? So that is true as well. Excuse me. And then E says the probability of receiving 32 calls. So the probability of x being equal to 32 between 9 and 10 a.m. So it's no longer 5 per 5 minutes. It's no longer per 30 minutes. It's now per hour, right? And what is an hour in minutes? 60 minutes. So I need a new lambda per 60 minutes. I like to use the original lambda just in case I made a mistake when I converted the 1 per 30 minutes, right? So it says the probability of receiving 32 calls between 9 and 10 a.m. next Monday is this, right? So the first thing that I have to do is to change my lambda. The original lambda was 3 is equal to 5 minutes. Now I need it per 60 minutes. So it's going to be lambda is equal to 60 minutes, and I cross multiply, right? And then 3 times 60, 180, 5 times lambda, 5 lambda. And then you divide the 180 by the 5. Your lambda is 36 per 60 minutes, right? That's the lambda you now substitute into your formula. So it's going to be the probability of x being equal to 32 is equal to e to the power of negative 36, the lambda, times 36 over, to the power of 32, the x value, over x factorial, and our x is 32 factorial. And the answer that you get is 0,0558. However, they are saying it's 0,837, so the false statement is E. Therefore, E is false. So the correct answer for number 3 is E, because we're looking for what is false, right? And then question 4 says, management of an office building recorded the quarterly data. So I'm working with quarterly data. So my P is equal to 4, and it is even, meaning when I'm looking for the trend, I need to use my CMAV. If it was odd, I use my MAV, meaning the middle number is the one you are looking for. So you just take it as it is, right? So on electricity consumption, so my Y is my electricity consumption, right? It's what I'm focusing on. So what I'm interested in is the subjects of whatever I'm working with. At the office building over time. So they say the data selected figures, the data selected figures for decomposition analysis are given in table 1. The time series data are presented graphically in figure 1. So if you guys check with this whole thing, what do you have to do? You need to isolate the trend. How can you isolate something that is not there? Meaning there is trend, right? And then they say detrend. How can you detrend something that's not there, right? So trend is there. Then they talk about seasonality, right? In adjusted season, meaning the seasonality was there, we had to correct it, right? So adjusted and corrected is the same thing. So adjusted or corrected seasonality, meaning in this data that I am working with, there is trend and seasonality. So if a question had to come and ask you, which is decomposition the best one, or is it Brown's method, or is it Hall's method, or is it Winter's method? You would say that decomposition is the best one because there is trend and seasonality. Brown's method would not be the most appropriate because Brown's method is only used when there is white noise, right? And you remember what white noise is. You could be thinking that a line is a linear line, but all of a sudden you have this, right? And then it goes back to being linear. So we call this a white noise, a random fluctuation, right? So this is a random fluctuation. That is what white noise is, right? Okay, let's go on to the data. Let's go on to the questions. So the first question says, rounding all intermediate values to 4 decimal places, calculate the missing values A and B in table 2. So I go to the table A and B. A is looking for isolating the trend, B is looking for detrending. So I need to find the trend for A, right? And remember I said P is 4, right? So I need to take my portions in 4s, right? So what you do is you mark where you are, right? So I'm here, I'm at A, right? And then you go 2 steps upwards, so it's gonna be 1, 2, right? And then you make a big thingy, 1, 2, and then the one you are in, and then 2 steps downwards, 2 steps downwards. So this is the big box I'm working with, right? Now you are in this big box. Take the first 4. So I took the first 4, and then I took the next 4, right? So if you check in what I shaded, what is repeating? 4,8, 4,4, and 6,1 are repeating in both these boxes, in this box and in this box, right? So what you do is you take those that are not repeating, you add them together first. So those that are not repeating in this case is 5,6 and 5,9. So 5,6 plus 5,9, right? Plus 2 times those that are repeating. Don't add them all together, exam strategy. 2 times all those that are repeating. So it's going to be 2 times 4,8 plus 4,4 plus 4 plus 6,1. And then you divide this whole thing by 8. And then the answer that you get is 5,2625. So that is your A value. And then your B is detrending. How do I do something? To detrend, you need to take the Y minus your trend, right? So it's going to be 4,4 minus the A to give me my B. So my B is going to be 4,4 minus this value, 5,2625, which is going to be equal to negative 0,8625. Make sure you show all your workings because they are going to be marking your workings, right? Okay, so there is 4.1 for us. 4.2 says, management of the office building intends to forecast electricity cost for the second quarter of 2017. Okay, second quarter of 2017 is where? Okay, so second quarter, you need to finish the table, right? We are at time 14 and at quarter 3. So it's going to be quarter 4 time 14. Sorry. Oh, sorry, 2016. I'm at time 14, so it's going to be time 15, right? Quarter 4 times 16, quarter 1 times guys, sorry, can I just fix this? So it's going to be 14, 15, 16, 17, and it's going to be 4, 1, 2. Oh, I was right. Okay, that's fine then. So I'm at time period 17, and I'm looking for the second quarter of 2017. So it's going to be T17, right? So that's what I said here. Second quarter of 2017 is T17, right? And then remember, this is the function that they gave me. So they gave me 5,0, this whole function, and I need to substitute T. But I also need to add or subtract the seasonality. I need to add the seasonality, right? So how do I find the seasonality? I need to add the corrected seasonality, right? This is my adjusted seasonality. This is my corrected seasonality. But if you check, how many do I have? I have 1, 2, 3, right? I have 3 seasonalities, right? And I need 1. So I don't go on and I do the table. I just say 0 minus all these 3 and I get it. Because remember, when we are correcting the season, we're going to have, for example, if you add all the numbers, right? If they said use the method of means, after you found your means for each quarter, you add the numbers, and whatever number you get, let's say it was positive 1,5, you need to now subtract, right, 1,5 divided by 4 in each quarter, right, to be able to correct the seasonality. And when you now add all the seasonality, they should give you 0. So meaning when I add all the seasonalities together, all the 4 seasonalities, I should get 0. So because I have 3 and I'm looking for the third one, I just say 0 minus all these. So it's going to be 0 minus a positive number. So it just stays 0.7364 minus 0.5490. But I have a negative number here. Negative times negative, positive. So I add the 0,4135, right? and this is the value that you have. So meaning the corrected season for the other one is negative 0.8719. Right, so that is the seasonality I will have to add here. Okay, so I have the formula is 5,019 plus 0,028 times t is 17 plus the seasonality of negative 0.8719. You put that in your calculator, this is what you get. So if you are not given this function, all you had to do is to find the deseasonalized data. So you take your y, subtracted your adjusted seasonality, find your deseasonalized data. Your x values were going to be your time, and your y values are going to be your deseasonalized data. And you would use your calculator, this button, right, the one that has x and y. So then you find your a and your b. Then you have your function, right? So b says when using Brown's exponential smoothing with a constant of 0.25, so my a is 0.25, the predicted value, the predicted value meaning y hat, for the second quarter of 2016, where's the second quarter of 2016? Second quarter of 2016 is time period 13. So they are telling me that y hat 13 is equal to 4,7346. Use this information to find the required forecast for the second quarter of 2017, right? So with Brown's method, just to remind you guys, we have three things. We have the smooth value, our a. We have the predicted value, our y hat t, and then we have the actual value, our y. So be careful what they gave you. Here they gave me the predicted value, y hat 13, meaning they gave me this, right? And remember, the smooth value, this value, predicts for the next time period. So if I have y13, what predicted y13? It was A12. So meaning they gave me A12 to be 4,7346. So that's what I said here. My A12 is 4,7346, right? So they said I must look for the second quarter of 2017. And what am I looking for? I'm looking for A14, right? Because 2017 is outside my range and I can't do extrapolation when I'm working with Brown's method. So my AN is going to predict anything that comes after time period 14, right? So I look for A14. To get A14, I need A13 because I have A12, right? So I need A13. So it's going to be the smooth value using your formula. It's going to be A of 0.25 times YT of 4.6 plus 1 minus A 0.75 times A T minus 1, right? A T minus 1. I'm at A13. So 13 minus 1, 12. So I need A12, which is the value that they gave me. Then the answer is going to be 4,70095. Now I can go ahead and get A14. It's going to be 0.25 times the Y value, 6,3 plus 0.75 times this previous value of 4,70095, and then I get this value. So that is my A14, right? And then C says, which of the two different forecasts A and B would you recommend recommend to management? Justify your answer. So they are saying, would you recommend Brown's method or would you recommend decomposition method? You'd recommend decomposition method because there is trend and seasonality. We only use Brown's method when there is only white noise. So the best one would be decomposition analysis, right? Then question 5 says, an internet search engine looks for a certain keyword in a sequence of independent websites. It is believed that 15% of the sites contain the keyword. Out of the first 10 websites, let X be the number of sites that contain the keyword. So when you see a probability of something occurring and N, it should click in your head that this is a binomial question. So binomial question. Right, so you should be in your formula sheet by now looking for the table that gives you binomial formulas, right? And then it says calculate the probability that at least 2 of the 10 websites contain the keyword. Remember with binomial, what is my range? My range is X is equal to 0, 1, 2, all the way to N. So my lower limit is 0, my upper limit is N. So they are saying calculate the probability of X being at least means greater than or equal to 2, right? Meaning I need to find 2 all the way to 10. But that's going to be a long calculation. So I'm just going to have 1 minus P x being less than 2, right? So I'll just calculate the probability of x being equal to 0 and 1 and take that whole amount and subtract it by 1, right? So this is what we do, right? So it's going to be probability of x being greater than or equal to 2, which is going to be equal to 1 minus the probability of x being less than 2. So 1 minus probability of x being equal to 0 and plus x being equal to 0. And when you put that in your calculator, you should get 0.4557. Just to remind you guys, the selection part, because the formula has the select. So it's going to be 5 shift CR, right? Shift division sign. That's how you'd find the select part. By that I mean the formula has this part that says n select x, right, times px to the power of n. Let me see. Where's my formula? Okay. Here's the formula. Px to the power of x times q. Q is 1 minus p, so times q to the power of n minus x, right? There's this part, excuse me, there's this part that says n select x. So that's what I was showing you guys. In this case, n is 10. So 10, let's say select 1. So that's how you find this part. And then here's just multiplying the probability of what you are interested in to the power of your x value times the complement of the probability you're interested in, raised to the power of your sample space minus your x. Okay, so that's what we did here. And this is the answer that we got, right? And then 5.2 says, find the standard deviation of x. You go to your formula sheet still, and then they said standard deviation. The variance formula is n times p times q. So the standard deviation is going to be the square root of this, right? So the standard deviation is going to be the square root of my n, 10, times p, the p that I'm interested in, 15%, times my q, 85%. And this is the answer that you get, 1,29, right? So, okay, this video is quite long, but I just want to finish. Question 6 says, patient records at a local hospital show that on weekends patients wait on average 10 minutes. So this is what is shown by records. So this is what is generally known to be true. So I'm assuming it would be my H0, but let's read the whole question. Before being attended at an emergency room, over the course of the few weekends, a newspaper blogger recorded the waiting time of 36 randomly selected patients and obtained an average waiting time of 11,2. So this is my n and this is my x bar with a standard deviation of 3,86. Waiting time to be seen in the ER is assumed to be approximately normally distributed. If the news blogger justified in thinking that the mean waiting time is different from the one stated, use a p-value. All right, so what an interesting question. So as I said, patient records what is generally known to be true. So my H0 is mu is equal to 10, right? And then someone went on and got a sample of 36, so my n is 36, and found that from that sample, the x bar is 11,2, and the standard deviation of that sample is 3,86, right? So they are telling me that waiting time is denoted by x, and x follows n, right? Okay, and then x follows n, and my mean is 10, and I'm not given the standard deviation, right? And my H1 is that the blogger thinks it's different, so mu is not equal to 0, right? And then remember, with p-values, what you are doing is that you are finding the test statistics. With p-values, there's no a, right, that you need to know. There's no significance level. So what you do is you do your test statistic and you find the probability for that test statistic, right? So I've listed my hypothesis. Now I'm calculating my test statistics. So if you guys check, the population standard deviation is not known. Oh, I'm not finding my formula sheet. You know that formula sheet that you guys have, that table that tells you your test statistics? Yes, that one. Use the second one because it shows you the one where the population standard deviation is not known. So this is the formula that I'm given there. So it's going to be x bar 11.2 minus 10 over the standard deviation of 3,86 divided by the square root of n. My n is 36. So divided by the square root of 36. And the answer that you get is 1,8653, right? And then the third one would be to do your probability, right? Remember I said a p-value is a probability, so I'm going to use this test statistic value to find that its probability. So they said different, right? So meaning it could be greater than, could be less than. So it's going to be the probability of t being greater than this value, or the probability of t being less than this value, right? So if you go to your t table, you will see that with 35 degrees of freedom, and you have this critical value, you will see that it's between the probability of 0,025 and 0,05. And remember, your t table standard form is greater than, meaning that if you need a less than, you need to take 1 minus. Hence, for the less than part, I took 1 minus this and 1 minus this, and this is what I got. Now I need to conclude. Remember, the P table has that table that you need to memorize from 0 to 1%. There's very strong evidence. 1 to 5, there's strong evidence. 5 to 10, there's moderate evidence. From 10 to 20, there's weak evidence. From 20 to 1, there's insufficient evidence, right? So you need to memorize that table. So here, for the probability of, so P will be an element of 1% to 5%, and there is strong evidence in favor of the alternative hypothesis that the mean time is greater than 10 minutes. So for this one, where we are saying P is greater than, T is greater than 1,8654, there is strong evidence in favor of that alternative hypothesis, because remember, its probability is between 2.5% and 5.5%. And if you remember the table I'm talking about, it's going to be between 2.5% and 5% is between 1% and 5%. And in this interval, we interpret that as there is strong evidence in favor of H1, right? And then for this one, we have a 95% and a 97.5%. So P is an element of 20% to 1, right? And there is insufficient evidence in favor of the alternative hypothesis that the mean time is less than 10 minutes. So there's evidence in support of the greater than part, but there is insufficient evidence in the less than parts, right? So that's how you would conclude. Question 7. Question 7 says, Okay. Question 7 says, a wholesaler stocks a certain product that sells particularly well on weekends. The data below are his stock levels on Fridays and following Monday of 4 randomly chosen weekends, right? So there is the Friday, there is the Monday, but there is something that happens in between, and that is the weekend, right? Meaning these are dependent data. With dependent data, there's going to be something that occurs before, a process in between, and something that happens after. So here it's dependent events, right? And then we are given these values, and they say find the 95% confidence interval for the average decrease in stock, right, over the weekend. So here they are hinting to you how you should define your difference. They are saying, they are actually answering the question, should I define the difference between these two as Monday minus Friday, or should I define it as Friday minus Monday? So if you check, they said a decrease in stock. So if you check which values are bigger than the others, this one is bigger than this one is bigger than this one. So the Friday ones are bigger than the Monday ones, right? And if there was a decrease, right, it means I took this value and I subtracted what was in between, and then I got the Monday, right? So it's going to be Friday minus Monday. But don't worry about this. I did say you should just define how you're finding the difference. So just say F minus M, and your answer is only going to be different in terms of the sign either way. So find the 95% confidence interval for the average decrease in stock over the weekends and state the assumptions used. So I assumed that they follow a normal distribution. And then if you go to that table that I told you about, that gives you your test statistics, that gives you your formulas for your confidence intervals, you'll find that the formula for that is D, difference of D plus or minus T degrees of freedom. So my N is 4, so the degrees of freedom are going to be 3 times my A. So my A in this case is going to be A over 2, so it's going to be 0,025 times SD over the square root of N. And I defined the difference to be F minus M, right? So you will go ahead and you find the differences between these, and this, and you'll get values. And you will use those values in your calculator to find the mean difference, right? Let's do it, guys. So it's gonna be set up to variance. Then I have my x value, so it's gonna be 2534 minus 1322 1793 minus 456 286 2890 minus 1704 213 2313 minus 882, right? Then on shift 1 variance 2, and the value that I get is 1291.5. So that is the mean difference, right? And then if you go to your t table, go to 3 degrees of freedom and go to the a value of 0.025, and you'll see that that t score is 3.1825. And then you substitute by the standard deviation, you'll find it the same way. So it'd be like on shift 1, right, 4, and then standard deviation number 4. And you got this long value, and then I want to store it, so I'm going to press shift RCLA. So this is stored under A now. So it's going to be just substituting into your formula. And remember, when you plus it, you're going to get a big number. So whatever you plus comes this side, whatever you subtract comes this side. Then this is your confidence interval. Question 8. Oh, this question paper is long. Okay, so at the factory, the length of training and the reduction in time spent assembling a mobile phone is investigated for 8 workers, right? So they are talking about length in training and reduction time. What would affect the other? Would the length in training affect the reduction time in assembling a phone, or the other way around? The training would affect the reduction time, right? Meaning the training is our independent variable, and our reduction time is dependent on your length of training. So this would be a dependent variable, meaning the length in training is X, the reduction in training is Y. It's very important for you to define this correctly, right? And then you use your formula, you use your calculator, I mean. So they say use the formula to find the least squares regression of reduction in time on length of training. So they said formula. Which formula? Y is equal to A plus BX. Don't go on and use that long formula where you find A using the formula and B using the formula. They said formula, so they mean this formula. They gave you a table, so you need to use your calculator. If they give you summary statistics, only then do you actually use the formula, the long formula, the one that has BX, right? That has YX, that long formula. You guys know that formula, right? So you go on and you substitute into your calculator. Let's just erase our calculator. So it's going to be set up to 2, right? And then you put your X and your Y. So it's going to be 4, 2, 2, 4, 2, 4, 6, 6. And they should be 8 values, yes. 2.6, 1.8, 2.0, 3.1, 2.6, 3.5, 4.8, 4.1, right? And then on shift 1, regression now 5. So my A value is just see, there's something I did wrong when I was substituting in the calculator. Oh no. Okay guys, I'm sure you guys know how to substitute in your calculators, né? I'm trying to save space. So I already did this question paper, and the A that I got was 0.9307. So just make sure you substitute correctly. Find your A, find your B, and this is your regression line. They can also call this regression line the line of best fit. Okay, the line of best fit. So yeah, and they say interpret the slope of the regression line calculated in 8.1. So the slope is my B. My B is my M, basically, if you think about the linear line from high school. So the slope is my B, and the B in this case is positive 0.57051. Since the B value is positive, it means that there's a positive linear relationship between the length of training and the reduction in time, right? Then 8.3 says calculate the error term. So the error term is your actual minus your predicted. What is the actual for the second value? 1.8. And then what is the predicted? The predicted is the one that you're going to predict using your formula. So I stored my formula under A plus B, right? And then they said for the second worker, so my X is going to be 2, right? Because I'm here. So this is my X value, right? And then you substitute, right? And the error is negative 0.2641. Question 9. We're almost done, guys. Please bear with me. What is the probability that the usage in a particular month exceeds 25 gigabytes? I need to read the question. Suppose that the monthly data usage by each employee at a company is approximately normally distributed with a mean of 20 and a standard deviation of 5 gigabytes. So they are telling me that X is the monthly data usage, and X is normally distributed with my mean as 20, my standard deviation is 5, meaning I need to square it. The standard deviation is known, meaning I'm reading from the Z table, right? 9.1 said, what is the probability that X exceeds? Exceeds means greater than, right? So probability of X being greater than 25. Remember, I'm at X, I need to get to Z. How do I do that? Subtract the mean, divide by standard deviation. So it's going to be the probability of Z being greater than 25 minus 20 over 5, which is going to be equal to the probability of Z being greater than 1. But on the Z table, the standard form is less than. So it's going to be probability of Z being less than the opposites of this sign. So it's going to be minus 1. Go to your Z table, and this is what you get. That's 9.2. We're almost done, guys. 9.2 says, for 25 random selected employees, what is the probability that their total data usage in a month exceeds 550 gigabytes? So they are saying for n is equal to 25, what is the probability that the sum of all the x's is greater than 555? So to remove this, I divide by n. So I divided by 25, right? And then I got that x is greater than 22. Because I divided by 25, I will start treating this as if it's the sample space, as if it's x bar. So it's going to be the probability of x being greater than 22, then probability of z being greater than 22 minus the mean of 20 over the square root of the standard deviation over my n. So my standard deviation in this case is 5, right? So it's over 5 over the square root of what? Of my n. My n is 25, so it's going to be 5 over 5. And then when you do this in your calculator, you get a 2, positive 2. But because the z-score is a less than, right? So the standard form of my z-score is less than. So to get to the what am I saying? I'm tired of talking. Okay. So I said we'd see the standard form of my Z table is less than, right? But in this case, I have a greater than, so I need to find the complement. I had a positive 2 with the greater than, so to make it less than, I need to have a negative 2. Then you go to your Z table. This is the probability that you find. Okay, last question, guys. Question 10. For those who've watched till this far, thank you so much, guys. I hope this really helps you. If you have any questions, please make sure you put them in the comment section. And if you haven't subscribed, please make sure that you do so. Okay, each of the following statements is either true or false. State with a valid reason whether the statement is true or false. No marks would be awarded if a valid reason is not given. So if the sample mean is less than the median, so it suggests that the data is positively skewed. No need to cram anything. You just do this table. So a lot of the data is to this side, right? Because it's positively skewed. From the left to the right, the ruler test. So you move from the left to the right? So a lot of the data should be this side. You start with the highest point, that is my mode. Then the middle point, my Q2. Then what is left, my mean in the measures of central tendency, right? And also the reason why the mean is going to be greater than all of these is because it is affected by a large number of positive numbers, right? So it's meant to be bigger than anything else. So here they are saying the sample mean is less than the sample median. They are saying the mean is this side, but that's not true. The mean is actually greater than the median. So this is false. Because for positively skewed data, the mode, which is this, is going to be less than my median because it's, my median, my Q2 is going to be greater than my mode, right? My Q2 is greater than my mode, but less than my mean. So that's why that is false. And then 10.2 says, for a sample of different types of cereal, it was found that a 30-gram serving of calorie count was 130 if a standard deviation with a standard deviation of 46.9. Right, so for calorie, we had a mean of 130 and a standard deviation of 46.9. And we are told that for sugar, we had a standard deviation of 5.8 and a standard deviation of 3.4. And they are saying, based on the information given, sugar is relatively less dispersed. What does less dispersed mean? Less spread, right? So they are saying sugar is less spread. To check that, you check which one is further away from the mean, right? So in this case, the sugar case, the X bar is 5.8 the standard deviation is 3,4. So the difference between the standard deviation and my mean is 2,4. When you go to calorie, the x bar is 130. The sample standard deviation is 46,9. So the difference between those is 83,1. So this one is more dispersed because the sample standard deviation is far away from the mean. However, here it's not that dispersed because it's less dispersed. The difference between my mean and where my standard deviation is small. So sugar is less dispersed. So that would be true. So sugar is less dispersed. And then we go on to 10.3. It says in hypothesis testing, if the null hypothesis is rejected at a 1% level of significance, it will also be rejected at a 5% level of significance. Okay, think about it. I'll draw this on a new page. Think about it. I'll just follow what I'm doing. Okay? So they are saying if you are rejecting at a 1% level, right? Let's say that you are rejecting at this level, right? So at this 1%, it's your rejecting. It's your rejection. Meaning you're accepting at a 99%, right? So this whole thing is 99%, right? So they are saying you rejected at this level. You accepted 99%, rejected at 1%. So they are saying it will also be rejected at a 5% level of significance. If you are rejecting at a 5% level of significance, it means that this area needs to increase, right? So from 1% to 5%. So this is now your rejection, right? Right? And you are only accepting at 95%. So meaning that it will also be rejected at the 5% level. Because the only way it would not be, the only way it would be accepted is if it's here. But it has a smaller chance of being here because the 99% is already touching here. The 1% is here, and when I'm at 5%, I'm touching the rejection region of 1%. So that would be true, right? Because 1%, the 5% already falls in the 1% region, right? Because 5% is going to be this area plus the area of 1%, meaning that 5% is already contained in the 1%. So I hope that helps you guys. And then last question, question 11. This is a long past paper. Says a large company is interested in determining whether an association exists between the commuting time of employees and their level of stress. So this is ringing chi-squared, 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 because I'm looking for the association between two things, right? And then it says table 5 gives a summary of 120 employees. So my N is 120. Selected expected values are given in brackets. What are expected values? My expected frequency. Okay, so the expected frequency is given in these brackets, and what I have outside of the brackets are the observed values, right? So they say calculate the missing value of A. So they want me to calculate the expected frequency or the expected value. This is the formula that you use, right? So I'm just going to show you how to do it. So it's multiplying the row total. So the row total for A is 35 times the column total. So it's going to be 35 times 58 over N. N is 120. So that's what I did here. And you get 16,916, right? So that is your A value. Then it says use p-values to test if there is an association between employee commuting times and work stress, right? So when you're using p-values, first list your hypothesis. H0 is there is no association between the commuting times and their stress levels. H1 is there is an association between the two, right? Always. Right, and then what do I now need to do? Now I need to find my test statistic. Remember with p-values, there's no critical value. There's always your test statistic. And depending on whether you are on the original p-values on chi-squared, you calculate them differently. So if you're on the original p-values, you calculate your test statistic based on the table, right? That table that tells you your confidence intervals and what. And then when you're under chi-squared, you will calculate your test statistic using the rules of chi-squared. That rule is this formula, right? So it says sum of observed minus expected squared over E, right? So that's what I need to do. I need to find all those things and add them together. So I'm going to show you for 1, right? So it's going to be 15, right? the observed, so 15 minus the expected frequency, right? So minus the A that I found, right? Square that over the A, and it's going to be 16,9166. Let's do the second one. For the second one, it's going to be the observed, 20 minus the expected frequency, 18,08 squared over the expected 18,08. And you do all that for every one of them, and you'll find that it is 7,369, right? Now you need to find the probability of that. Chi-squareds have their own table, just like the Z table and the T table. Guys, everything is just a mess here. I'm not sure where my table is, and I wanted to show you guys. Sorry, guys. So what you have to do is to find the degrees of freedom. And the degrees of freedom for your chi-squared will always be your row total minus 1 times your column total minus 1. So in this case, 3 minus 1, right? So I have 3 rows, so 3 minus 1 and 2 columns, so 2 minus 1, and the degrees of freedom is 2, right? So for chi-squared, you always use degrees of freedom and your A value, right? You'd use A if it was just the normal chi, but they said use P values, meaning I don't need an A. So I just need to find the probability, right, of chi being greater than 7,37 in my chi-squared table. Oh, I wish it was here. Let's see, guys. I honestly wish it was here. I will show you guys how to do it. Yo, guys, sorry, guys. And then you would see that it lies between 0,025 and 0,025, right? So between 5% and 2,5%, right? So meaning P is an element of 1% to 5%. Therefore, there is strong evidence in favor of the alternative hypothesis that computing time and work stress are associated. And that brings us to the end of this video. Thank you so much if you've watched till this far. And please don't forget to subscribe. Please don't forget about the bootcamp as well, the economics bootcamp. If you are interested, make sure you hit me up on WhatsApp and get yourself signed. Sign up for it. Just hit me on WhatsApp so that you sign up for it. Bye, guys.